Assalamualaikum dear students. I welcome you all in our today's class. Today we are going to discuss chapter 3 periodic properties of elements and chemical bond, which is a chapter of our chemistry first paper. As you can see, this chapter is very large, or I should say it's a bulky chapter, but this chapter is very vital for the admission test. If we look at the topics that covers all the important points of this chapter, we can see that we can see actually lots of triple stars. So all of the topics are somewhat of similar importance. But if you ask my opinion, then I would recommend to put more emphasis on P block element, because P block element will challenge your memory. Here some informations are there which is very difficult to recollect in the exam hall, and you will get puzzled. Moreover, P block is a group or is a block where metal, non-metal, and also metalloids coexist. So there are variations in the properties, and there are also special uses which are very much common in our medical admission test examinations. So I recommend all of you to focus more on P block elements to do better in the exam. And S block, D block, F block, all these are also important, but among them, I should recommend the transition elements. The transition elements, which are very important not only for our HSC exams, but also for our admission exams, not only medical admission test. In case of Dhaka University or any other university exam, you will find a question from this topic. So you have to clear the basic idea, you have to get the basic concept to ace the questions that appears from D block or as well as transition elements. In the bottom section, we can see periodic properties of element. This is such a topic which, if anyone understands, or if anyone can grasp the idea of the periodic trends, then he or she will be able to understand and answer all the questions that come from this topic. Here, I only recommend learn all the exceptions. Learn all the exceptions of the periodic trends. It can be from ionization energy, it can be from electron affinity, as well as electronegativity. So you should focus on the data which are exceptional, which is not, which does not fall under the typical trend, which is, I think you got what I tried to mean, and I think you will get much better idea in the class also. And chemical bond, van der Waals force, all of these are important, but very important for medical admission test, I should say hybridization of the orbitals. There are lots of questions in our exercise regarding hybridization, and you have tried a lot of hybridization, and you have practiced a lot regarding hybridization questions for the HSC exam as well. So you should focus on determination of hybridization, number of hybrid orbitals, and also shape of the structure, shape of the molecule is also dependent on the hybridization, right? So you should learn, focus more on hybridization topic. Last but not the least, this is a topic which is also easy to answer if you know the concept. Fazan's rule, and also the polarization concept, polarity concept. Polarity and polarization, many of you get puzzled in between these two. So you have to learn the basic idea about polarity and polarization and implement it in the exam. Today, we are not going to discuss all these topics. We are going to discuss only these three topics: classification of elements based on electronic configuration. And as far as I remember, the latest admission test, the last admission test, medical admission test, carry one questions from this topic. So this is very vital. And we kept S block element and F block elements in our today's section because these two are really short topic, and you need to learn some, not very large amount of information. You have to learn few information and the basic idea to answer all the questions that can come from this topic. So let's not delay anymore. Let's focus on the questions. But before that, you should know that repeatedly we got questions from this classification of elements based on electronic configuration. What kind of questions usually appear from this topic? Let's first clarify this. You may need to find out group and period of an element. You may also need to determine the electronic configuration, which is not only relevant to this topic, but also relevant to the quantum number topic. So you need to determine the electronic configuration, which is also helpful to determine the group and period. And lastly, some numerical informations. Some numerical informations are there. What are the, how many elements are there in S block, how many elements are there in P block, D block, F block? These are frequently asked questions in the exam. So this numerical information can appear in the exam as well. Okay, now let's see what are the questions that usually appear in the medical admission test from this topic. Our first question appeared in the medical admission test 22 to 23 session. It is, what is the period and group of lead in periodic table? Okay, first of all, how can we answer this type of question? In case of determining the period and group, first we have to know the atomic number of the element provided. If you know the atomic number, then we can determine the group or period by determining the electronic configuration. According to the electronic configuration, we know that the number of electron in valence shell actually determines the group, and also number of, actually not number, I should say highest principal quantum number of valence shell represents the period. But this is the ideal approach, but it is very time consuming, and in an exam hall for solving an MCQ, you don't have to follow the appropriate rules always. You have to find out the shortcut. You have to find out the easiest way to determine the answer. So in this case, as we can see, there is an element named lead. If you know the position of group 14, if you know the members of different S block and P block elements according to group, then it will be easier to determine the position using the mnemonic. For the group 14 elements, we have a mnemonic in Bangla, which I am writing it down. But first, I try to recollect the mnemonic and write down the element's name: carbon, silicon, germanium, stannum, lead, flerovium. I didn't recollect all those elements by the name only. I remember the mnemonic. What are those? Kamal, Shigroi, Genius, Soniake, Abe, Fire. So once you can recollect that lead is placed in group 14, then it is easier for you. As we can see, there are two options having group 14. Now we have to choose between these two. For this, again, this mnemonic will help you. How? As you know, this carbon is from second group. So second period. So second period, third, fourth, fifth, sixth. So the period will be sixth. So recollecting the mnemonic of group, we can easily determine that lead is placed in sixth period and under the group 14. This group 14 is a very important and very crucial group. We have to remember at least a few points regarding carbon, silicon, and lead. These are celebrity elements in this group. But now we are discussing the way to determine period and group. Suppose you don't know that lead is within the group 14. You don't know the group, but you do recall the atomic number. Then would you follow this procedure? I mean, you will be trying to find out the electronic configuration of an atom possessing atomic number 82 would be ridiculous in terms of the time constraint in the admission hall. So we have to find out a better approach or a more sustainable way to determine the correct answer in the shortest possible time. What can be that? For that, you need to recollect the inert gas. You need to recollect the inert gas atomic numbers. As I'm writing it down, you should know that all the inert gases are placed in group 18. And if I write down serially, then I should write in this way: 2, 10, 18, 36, 54, 86, 118. These are the atomic numbers of the inert gas. If I write down their symbols, then it would be helium, neon, argon, xenon, krypton, radon, oganesson. All of you or some of you may be wondering, why would I need inert gas to determine the period and group of lead? As I have said earlier, suppose you don't know that lead lies in the group 14. You don't know the position of lead. You only know that lead have an atomic number of 82. It is quite impossible to determine the electronic configuration just knowing that the atomic number is 82. So what would be our approach? We'll just try to find out the nearest inert gas to that atomic number that we know. So we know that suppose this is an element X, their atomic number is 82. Now I need to determine its position. So what would be the approach? We'll find out the nearest inert gas to this number 82. We know our nearest inert gas will be radon. Radon got an atomic number of 86. So your common sense will tell you that since radon is in the group 18, so if I subtract 82 from 86, we'll get 4. And if we subtract 14, if we subtract 4 from 18, we will get 14. I mean, if it is in group 18, then 87 will be in group 17, 86 will be in group 16, 85. Sorry, I'm going in the wrong direction. If 86 in group 18, then 85 will be in the group 17. 84 will be in the group 16. Group 16, and also 83 will be in the group 15, as well as in this way, we will find out that group 14 will contain the atomic number 82. So if we know the atomic number, ideal approach will be comparing with the nearest inert gas. And if we can recollect the mnemonics of group, if we can recollect the group mnemonic, then we can determine this way. So make it short, I should say, if you face any question regarding determination of period and group of a certain element, then we will try to go with this approach. I mean, using group mnemonic is the fastest way to get the answer. But if you fail to recall that, then you have to compare the inert gas atomic number with the provided atomic number. Thus, you can determine easily the groups and periods. Okay, but if you have no other resource left, then you might follow this electronic configuration approach, which is ideal but very time consuming in the exam hall. And for the last time, if an atomic number more than 50 or 60 comes in the exam hall as a question to determine period and group, then I think this type of approach would be the ideal one. Okay, let's focus on the next question. Which element in the periodic table are called ideal element? First of all, you just don't call anyone ideal without any reason. To be ideal, you need to abide by all the rules. I mean, he's an ideal student. He's an ideal kid. How can we say that? Once we certify that he follows all the instructions, he follows all what elders say or teachers say, I think we can label him or her as ideal. Similarly, our ideal elements follow all the rules that are imposed on them due to their presence in the periodic table. What are the rules that we are talking about? We are talking about Aufbau rule, mostly Aufbau principle. If we see at the periodic table, then we can easily understand or easily grasp the fact that group S block and P block elements usually follow the Aufbau rules. There are no exceptions in following Aufbau rule in S block or P block. We rather find it in D block or F block, but not in S block and P block. Moreover, we can see that our second and third period only contains S block and P block element. That's why we can also state that second and third period elements are ideal. Those who are ideal, they can also be labeled as representative. So you may find question as which are called ideal elements. You may also find question as which can be called as representative element. You know that in our modern periodic table, there are 18 groups and 7 periods, right? But I mean, a few years ago also, we did not label the group number as 18. Rather, we used to think that the group is only 9 and all the groups have some subgroups. If we still believe that subgrouping system, then we should say that S block and P block elements are within the A subgroup. I mean, if you see anything written as 1A, 2A, then you can say that these are S block element. If anyone is within the 3A, 4A, 5A, 6A group, then we should say that they are within the P block group or P block. They can be called as P block elements. So S block and P block falls within the subgroup A, and rest of the blocks, I mean D and F blocks, are within the D subgrouping system. So we can also write that all the A subgroup elements can also be labeled as ideal or representative element. Okay. Now let's solve this question. We can see one option, which is group 1 element. group 1 element can be called ideal, but there are some issues that which is the better option here. Group 1 elements, certainly these are ideal elements, they follow the Aufbau rule, but we have to search for a better answer which covers more ideal elements. Elements of the first period also contain only S and P block, which is hydrogen and helium, but we are opting for better answers. In case of option C, we are observing that here it is written elements of second and third period, which is already stated here. In second and third period, we do contain, or we do have 80, total 16 elements. 16 elements are there which are ideal. So option C covers more elements than the rest of the options. For this reason, we can state that here the best answer will be option C. Option D is nowhere near to the answer because group 3 elements are within the D block, and D block elements are not ideal or representative element. So final conclusion is the answer will be C. So here the learning point is this: you have to learn which elements can be labeled as ideal or representative elements. Okay, so if you can remember or recall all these three, I think it would not be a hassle to answer this question. Next question, we find that in periodic table, which group's elements are oxidizing agent? Okay, this is a really interesting question. As we know, oxidizing agent, oxidizing agent, or oxidant. What does oxidant do? They accept electron. They accept electron. Oxidizing agent or oxidants accept electron. Since they require electron, they will be electrophile, or they are element of higher electronegativity or higher electron affinity. If some element possesses higher electronegativity or higher electron affinity, then they accept or they try to pull the electrons towards themselves. As we know in our periodic table, from left to right, electron affinity or electronegativity gets higher, and it does not get maximum value in the group 18 section. Group 18 are ideal elements. They don't require anything. They are ideal. All the elements try to be like them. So we are not considering group 18 here as answer. We are considering the group immediately before group 18, and that would be group 17, which is also known as halogens. They are known as halogens not because of their oxidant nature, rather they are called halogen because we find them in seaweeds. Okay, that's why they are called halogens. And you should also know that scientist Berzelius, who is also known for vital force theory, is responsible for this naming. Okay, anyway, this answer will be group 17. Group 16 is also oxidant, but it is of lesser potential, or it is a less strong or weaker oxidant than the group 17 elements. Let's move on to the next question. So in this question, we can say the fundamental basis of periodic table is what? In our book, fundamental basis of periodic table is written in two area. Here it is written in such a way that the atomic number and electronic configuration, is the fundamental basis of periodic table. This is written in our book, but in another part of that book also writes in the following way that the actual basis or actual fundamental basis of periodic table will be electronic configuration. So we got the better option here. The better option or the better answer will be electronic configuration. It is not atomic number. Okay, so we should write, or we should mark electronic configuration as the correct answer for this question. Moreover, I should also write down that atomic mass is the basis of periodic table of Mendeleev. Mendeleev is also known as the father of modern periodic table, but he did a mistake. He arranged the elements on the basis of their hierarchy of their atomic mass. But if we arrange all the elements according to their atomic mass, then we will find a lot of discrepancies in some areas of the periodic table. So to solve all those, Henry J. Moseley discovered atomic number, and Niels Bohr came out with this concept that we can easily avoid all those discrepancies that are arising in the periodic table of Mendeleev by just replacing or rearranging the elements according to their atomic number. Then we got the modern periodic table, which is also known as Bohr's periodic table, or the long form of periodic table is also known as Bohr's periodic table. Okay, which of the following is correct about group 3A element? See, as I have already mentioning that the subgrouping system was used to prevail not a few years ago. I mean, it used to prevail around 10 to 15 years ago. But still, we find some questions in our book regarding the subgrouping system. Group 3 actually represents the group 3. No, it represents group 13. It represents group 13, not group 3. It represents group 13. And now, which one is correct about group 13? Aluminium, indium, gallium. These are not correct. Why? First of all, this aluminium, actually its atomic number will be 13, not 31. And indium gallium is also incorrect. Only correct option here, we can see boron. And in this case, I also write all the members of the group 13 to easily understand or recall all the elements. I should write down that boron, aluminium, indium, thallium, nihonium. Actually, I have missed an element, which is germanium. Boron, aluminium, gallium, not germanium, it should be gallium, indium, thallium, and nihonium. I have recalled these elements with this mnemonic: Bonn, Amar, Gallo, India, Thailand, Nepal. This is group 13, which are also known as icosagen. There are some speciality of this group 13 element. They usually form compounds which lacks electron. So usually they generate electrophiles. In their compounds, octet usually stays incomplete. These are some key facts that you should recall regarding group 30. Next question, we can see what is the group of the element with valence electronic configuration of NS2 NP5. If we see such valence electronic configuration, then we should sum up the electron number to determine the group. But we have to add 10 for this. For p block elements, for p block, the group number can be determined this way. P block NS NP. This NS is always 2 and NP can be 1 to 6. Sum plus 10 will get you the group number. Okay, so you got 2, you got 5, 5 plus 2 will be equal to 7, and you have to add 10, and you will get the correct answer, which is 17, the group of the halogens. Position of yttrium in the periodic table. See, this yttrium, here we can see there is atomic number, so we can go in that direction, and we can see the symbol as well, so we can also use the mnemonic if we know. Normally, we do, we can easily remember the mnemonics of group 1, group 2, group 13 to 18. I mean, the S block and P block elements are well known to us, but yttrium is a group, D block element. It is quite difficult for someone to recollect all the groups of the D block, but I have to say that though D block is a huge block to recall, but we should try to recall the members of group 3 and group 12 at least. Where these are located, we know group 3 is the first group of D block, and group 12 is the last group of D block. And we also know that D block elements are distributed in 4 periods, which are 4, 5, 6, 7. And the group numbers can be written down as 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I complete that partition, it would look like this. Now it's complete. I do not recommend you to remember all the elements. I just want you to remember the elements in group 3 and elements in group 12. So for group 3 elements, you can easily recall with this mnemonic, Skule Jaben, scandium zinc. Just think in this way, that you're saying that you're looking at a child with a school bag and crying in the home. He's not willing to go to the school, and you're asking, Skule Jaben, Keno Kaden, Keno Kaden. Keno means y, and y represents y. So we already found our element. It is located in group 3. Skule Jaben, Keno Kaden. So that kid is trying to reply with this, half Hujur Laden. I mean, he got a very strict teacher named Laden, half Hujur Laden. And lastly, after hearing all these information, what is your recommendation to that kid? You said him that এখন থেকে রোজ কাঁদবেন. I mean, you are telling him to go to school by saying this. Whatever, these are mnemonic and weird mnemonics, I should say, but it will enable you to remember all these elements. It helped me. I think it will help you as well. I have written this fella here because I can't place him in the period 7, group 3. There is no room for him. And we should also acknowledge the fact that there are 30 elements right here. I mean, 28 elements are placed here who do not have any room in this 2 period in group 3, but they are the members of group 3 and period 6 and 7 respectively. They are called lanthanide and actinide series, right? Whatever, I have to remember at least the members of the group 3 and the members of the group 12. So the mnemonic I am repeating, just repeat with me. Skule jaben, keno kaden, half hujur laden, ekhon theke roz kanben. So jai hok, whatever, I should say that these mnemonics are really effective and it will help you to find out the answer. Moreover, you should recall the elements, or you should know the position of the elements of at least group 4. It can be easily remembered this way. School theke bhai, choto, me, faria, ke, niye, koi, jan. I have also already mentioned this mnemonic in the earlier master classes. You should go and check. And if you can recollect these elements, you can also easily recollect that the copper group will contain other ornamental elements like silver, gold, and you can also see or notice that platinum lies just beside gold. In this way, you have identified the positions of at least here 10 elements, and there are 6, 3, 9, so almost 19 or 20 elements out of 41 elements in D block. You can easily identify their position in this way. So if we don't know the atomic number of yttrium, we can determine the position using the mnemonic. In this way, we can say that it lies within the 5th period, group 3. So C, option C will be the correct answer. But suppose you don't know that this is yttrium. I mean, here the question appeared this way: what will be the period and group of an element of having atomic number of 39? In that case, you should already know that we have to compare it with the nearest inert gas. The immediate inert gas after 39, it will be what? It will be 54, and immediate earlier inert gas will be 36. Which is near? I think which one is nearer? Nearer one will be 36. So if we compare it with the nearest inert gas, which is helium, neon, argon. Argon is 18, argon, xenon, helium, neon, argon, krypton. Actually, it will be krypton. We know that helium have an atomic number of 2, neon has an atomic number of 10, argon got 18, and krypton got 36. First period, second period, third period, fourth period. So anything above 36 will be in the period 5 or more. Since it is just 3 elements later, I mean 39 will be 3 elements later than later for 36. So we can easily say that it will be group 3 and its position will be group period 5. So in this way, I can determine the group number by comparing with its nearest inner case. It can be earlier one, it can be later one, but I think you can easily understand what is the approach here. So using this approach, I think you can always determine the answer easily. Which electron configuration is correct? In this case, the first one is correct. Why? As we know, zinc got an atomic number of 30. What will be its atomic configuration? It will be like this: 1s2, 2s2, 2p, 6, 3s2, 3p, 6, 4s2, 3d, 10. Right? When it becomes an ion, I mean zinc 2 plus ion, then it will leave 2 electrons to get that double positive charge. And we know the last which electron goes away while forming cation. In cation, the electron present in the last shell will go first. So here the electrons in the fourth shell will go away, and rest of the formula can be written this way in short. Because if we remove this 3d10, then we get the configuration of argon. This is the configuration of argon. So we can write argon 3d10 for zinc 2 plus. We don't have to check others because we got the correct answer. Elements of which group are called chalcogen? We know ore forming elements, which are found in the ores, are called chalcogens. And we should say that our group 16 elements actually, first four members, which are oxygen, sulfur, selenium, tellurium. Oxygen, sulfur, selenium, tellurium. These are the most common or available compounds found in ore. That's why they're called chalcogens. So answer will be group 16. What are the other names of group 15? Group 15 can be written as or can be labeled as pnictogens. Why? Actually, it is quite tragic to call them pnictogen because only nitrogen of this group creates problem while breathing. I mean, it has deleterious effect in our breathing, or it hinders our breathing. That's why they are called, nitrogen should be called pnictogen, but since nitrogen is the leader of the group, the top one or the superior one, that's why all the members are also labeled as pnictogens. It is like labeling a family of normal people as terrorist family because of having a terrorist kid in that household. Similar way, we are labeling pnictogens, group 15 as pnictogens only because of nitrogen. Group 13, I have already mentioned that they are called icosagens, and group 14 can be labeled as crystallogen. Okay, which are metalloids? We know that we got 118 elements. Among 118 elements, there are metals, non-metals, and metalloids. Number of metal is around 94. Number of non-metal is 18. And rest 6 elements are called metalloids. These 6 elements are very important to remember because sometimes questions appear this way, that which one is metalloid. Look at this question. If you don't know them, then you can't identify them. So we have to recall all these 6 elements with a mnemonic at least. It can be remembered this way: boro, chele, jeno, aaj, shop theke, matal. So what do we mean by this? Boro will be stated as boron, chele will be silicon, jano will be germanium, aaj will be arsenic, shop will be antimony, theke will be tellurium, and with matal, we don't represent any other metal. We rather trying to remember this mnemonic as a mnemonic of remembering metalloids using the word matal. Okay, so boron, silicon, germanium, arsenic, antimony, tellurium. We can see silicon, we can see germanium, we can see arsenic. Rest of the option, antimony can be arsenic, but rest 2 are not. Right? So among all the options, the better answer will be A. Since I have already written the metals and non-metals, I should also write down some more information regarding these. There are some solid metals, there are some liquid metal, there are some gaseous metal. The number of solid non-metal is 6. The number of liquid non-metal is 1, which is bromine. And the remaining 11 non-metals are in gaseous state. We should also know all the solid non-metals. The solid non-metals can be remembered this way: IC at CP shop. IC at CP shop. How do we remember with this? I for iodine, Se for selenium, not Selena Gomez. At for astatine, C for carbon, P for phosphorus, and lastly S for sulfur. So we got all the 6 elements or 6 non-metals which are in solid state at room temperature. And lastly, we should also know some metals are there which are liquid at room temperature. What are those? We can remember or recall them in this way: France, Gie, Hagi, size, francium, gallium, mercury, cesium. These are the common metals which are normally liquid at the room temperature. But if you get all these 4 in a question asking about which one is the liquid metal, then you have to mark mercury as the right answer, because out of all these 3, mercury is the most known metal or most known liquid metal, or which is available at liquid state at room temperature. So we should mark or remember mercury in a special way. Okay, I think we have already provided the necessary informations regarding this topic for the admission test. Let's move on. In which group rare earth metals are there, or rare earth metals are present? Actually, our lanthanides, and actinoids, which are placed at the bottom of our periodic table due to no room in group 3. These are called rare earth metals. Rare earth metals are really important. We know lanthanum to lutetium, actinium to lawrencium, These are called lanthanoid series or actinoid series. We should also remember the atomic numbers as well, 57 to 71, 89 to 103. Actually, if you can remember 57 and 89, just add up 14 with them, you will get the atomic number of the last one. Why these are important? Because sometimes such question also can appear in the exam that tell me the group and period of an element of having atomic number of, suppose, 67. You get puzzled easily. You can think that way that I don't know the electronic configuration of atomic number 67. It's okay if you don't know. You can easily say that or state that without any calculation, that since it is within 57 and 71, so it is within the lanthanoid series, and the lanthanoid series element certainly have group 3 and period 6 in their identity. So rare earth metals are lanthanoids or actinoids, and they are also placed in group 3, so the answer will be group 3. Okay, you should also know that group 3 is the group which possesses maximum number of element. Maximum number of element. How many elements are there in group 3? 32. 32 elements are there within group 3. Okay, which group elements are strong oxidants in periodic table? Strong oxidants will be at the right side of the periodic table. So group 17 will be the answer. We have already answered a similar question earlier. What is the number of elements discovered and approved by IUPAC organization till 2016? The answer is very simple. It's 118. How many periods were there in the periodic table of Mendeleev? It is interesting. We know in 1869, Mendeleev, father of periodic table, proposed a table on the basis of atomic mass. On the basis of atomic mass, he formulated a table possessing 12 periods and 8 groups. 12 periods and 8 groups. In our modern periodic table, we see that the number of groups are much higher than the number of periods. But in case of Mendeleev's periodic table, we find the opposite. We can see the number of groups is less than the number of periods. But you might think in this way, if you have a table of having 8 columns and 12 rows, then there will be 96 slots in that table. 8 into 12, so there will be 96 slots. But did Mendeleev placed 96 elements back then? No. Mendeleev's periodic table only contained 63 elements, but he had a table of 96 slots. But here is the twist. He could have arranged all the elements within a table that possesses or contain only 63 slots, but he didn't do that because he knew all the vacant slot will be filled up by the newly discovered elements with the following characteristics. He could predict the characteristics of the elements that can be placed in that area. And in his lifetime and also after his death, elements were getting discovered and Mendeleev's prophecy were being proved as truth. That's why Mendeleev is considered as the father of the periodic table. Though he got it in the wrong way, but still, it was the first ideal approach to assemble all the elements according to their characteristics. So we still recall him as the father of periodic table. So how many periods were there in the periodic table of Mendeleev? The answer will be 12. Next question, who is the father of periodic table? I think I have already answered this question, which is Mendeleev. Mostly, I have already stated the discoverer of atomic number. Atomic number. How many groups and periods are there in Mendeleev's periodic table? I have already answered that, 8 and 12. Sometimes, due to hurry, we fail to answer this correctly because there is also an option which is 12, 8. For this question, I should give a free advice to all of you that read carefully before marking. This is the only ideal advice that I can provide. We do hate such experience in our exam hall that just marking a question, we got to understand that that was wrong. Actually, it is a very depressing situation at the exam hall. It demoralizes you a lot. That's why some of the valuable time gets lost, and sometimes the whole exam gets wasted because of some silly mistake. You get 0. Okay, let's not waste any more time. We go for what is the group determinant of the element. We know the group determinant of an element will be the number of outer electron. Actually, it can be stated as valence electron. Number of valence electron. Period of position of element is determined. Period of element, I think there is no need to state position. We can only say that period of element is determined by principal quantum number of the outermost shell. Not outer shell, I should say that it is outermost shell. So the answer will be P. What are the representative elements? I have already solved this question, right? S block, representative element, D block, not. S and P block, better answer. Okay, so answer will be C. Which of the following elements does not belong to the indicated family? Actually, which one is correct or which one is a mismatch? This is such a question. Copper is within the coinage metal. Coinage metal contains copper, silver, gold. Let's see how much you can recall from our today's class. Let's see if you can say or recall the group number of coinage metal. Try to recall. I give you 3 seconds. 3, 2, 1. I think you have already found the answer since zinc is within the group 12. So copper will be in group 11. So rest of the elements are within the group 11. Next, lanthanum alkaline earth metal. Lanthanum alkaline earth metal. No, actually lanthanum is not within the alkaline earth metal. Alkaline earth metal are group 2 elements. Rather, lanthanum can be stated as rare earth metal. So it is an interesting question that many of you might fail to answer correctly. I or iodine is within the halogen. Cerium is also within the rare earth metal. Okay. The electronic configuration of an element, argon 3d10 4s1. Since we have solved a similar question earlier, we can easily say that it will be copper, right? So what will be the position of this element? A trick, I should mention an easy trick for the 4th period. What are the 4th period elements? I've already mentioned the mnemonic. I repeat it again. School থেকে ভাই ছোট মেয়ে ফারিয়াকে নিয়ে কই যান. Okay, this is the list of metals which is within the 4th period. And 4th period, D block starts with group 3. How can we remember that? Just look at the atomic number. If you add up the atomic number, you will get the group number. See, 23, 25, 24, 6, 25, 7, 26, 8. In this way, you can easily determine the group number for elements 21 to 29. Why it is important? Because their atomic number the atomic number they have is quite similar to the number of valence electron as it is related to their group number. We have already stated that the number of valence electron or the sum of the valence electron represents the number of group. So if you do know that the atomic number digits can be added up to get the group number, then you can easily assume the valence shell structure in this way, like 2 1. So it will be it will be what? It will be nd2 ns2 nd1. It will be ns2 nd1. In this way we can determine the electron number of the d of that d shell, d subshell or s subshell. It will be like this: nd1 nd1 ns2. Similarly, it will be nd2 ns2. In this way, we can easily determine the valence electronic configuration, and it is also helpful in determining the correct answer for such question where it is asked that which one possesses the highest odd number of electron. Okay, in this way, which one will be the answer? Iron, chromium, copper. In this, we have found plenty of questions or plenty of this type of question in the quantum number section. Anyway, we can say that this is the formula for copper, and if we add up their valence shell configuration or valence shell electron, we can easily state that it is within the group 11, and since argon is within the period 3, so any element which possesses higher atomic number than argon will be certainly in the group 4 at least. So the answer will be 4th period, group 11, and to be precise, the answer will be copper. In which order are the various elements arranged in modern periodic table? Alphabetically, no. Atomic level, no. The answer will be atomic number. What is the maximum electron capacity? Maximum electron capacity at 5th energy level. We know if an energy level can be represented as S, then the highest electron capacity will be 2n square. So for this question, it will be 2 into 5 square, which will be 50. Though it can possess 50 electron, but in reality, it does not contain 50 electron. Highest it contains 32 electron. Highest. Okay, now we will start on S block element. From S block elements, we can see that medical admission test 1920, 1718, 1617, almost chronologically it appeared. S block elements got some questions in previous medical admission test. But what are the types of questions are usually there? Some numerical information like the number of elements, number of metals, number of non-metals within the S block. Some questions can be due to or related to their property. Property means which elements are easier to cut with knife. I mean, you know all the answers, which is sodium. Which elements does not show any color in flame test? Such questions can appear about which is relevant to their property in the medical admission test. And I should say or assure you that S block element does not have any such information which is very difficult to remember. It is a very easy topic. If you once do my class or thoroughly read the chapter, you will be able to realize that within a second. First question: which one is the order of the number of element in S block and P block? We know that S block got 14 elements and P block got 36 elements. In case of S block, there are, if I note down this way, number of group, number of period, for S block and P block. If I note it down, I can say that S block contain 3 groups, which are group 1, group 2, and group 18, since helium is also within the S block. P block possesses 6 groups, which are group 13 to group 18. S block elements are well distributed within 7 periods. All the periods contain some S block element. In fact, only the second period contain not second period, actually all the periods contain 2 elements in S block. So that's why, since there are 7 periods, if you multiply it with 2, you will get the answer, which is 14. And P block is also distributed within 6 period. First period does not contain or possess any P block element. That's why we can say that from second to 7th period, these 6 periods possess P block elements. 6 period, 6 group, 6 into 6, the number will be 36. Which one is the chemical formula of gypsum? It is a very important question. It appeared in the admission test as well. The answer will be calcium sulfate dot 2H2O. If I rearrange the formula in this way, calcium sulfate 2 molecule and 1 molecule of water, then it will be named as plaster of Paris, which is also important to remember for medical admission test. Once you get to become an orthopedician or orthopedic physician, you will be able to know more regarding plaster of Paris. You will also be able to know regarding plaster of Paris if you become a medical technologist in the orthopedic section, but I think you are not talking about that. Okay. What is the chemical formula of plaster of Paris? Speak of the devil, it appeared already. The answer, calcium sulfate 2 molecule and water will be, no, this will not be the correct answer. The correct answer will be calcium sulfate 2 molecule, but the water will be 1 molecule. This one will be the correct answer, not the 2 molecule water one. Okay, which one is the saturated aquatic solution of sodium chloride? Saturated aquatic solution of sodium chloride is called brine. Which pair is correct? Sodium nuclear reaction, caustic soda, water gas formation, sodium carbonate antiseptic, sodium chloride formation of rubber. Very interesting pair. Actually, for nuclear reaction, sodium can be used. Though sodium do not contain any radioactive isotope, but it can be used in case of nuclear reaction. So for this reason, the option A will be the correct answer. But rest of the options are not correct. In this question, we see that which is correct about group 1A and group 2A elements. Atomic mass of lithium is 6.939, atomic radius of sodium. Actually, these are the questions which appeared long ago. In that time, the book contained such information. We just try to understand, just read the question and just know the correct answer only. We don't have to pursue this type of information anymore because we don't have this kind of information, not in our latest edition book, and also we don't see such questions appear in the admission test any longer. So in this case, the correct answer actually atomic mass of lithium is 6.939. Sodium, in case of sodium, it is not 0.147 nanometer, and also potassium ionic radius is also not near to 0.157 nanometer. Okay, let's focus on the next question. Sodium nitrate is found in what? In chili saltpeter, sodium nitrate is found. Which pair is right? Phosphorite, calcium fluoride, it is correct? No, it is not correct. Dolomite, this is very important. Calcium carbonate dot magnesium carbonate is also known as dolomite. Moreover, magnesium sulfate dot 7H2O, it is also known as Epsom salt. This is also known as Epsom salt. And KCl magnesium chloride 6H2O, it is also known as carnallite. Okay, what is the number of s-Bloch element? It is also answered. It was also answered in the, 3 to 4 questions ago. The answer will be 14. Which one is s-Bloch element? It is very easy. It is potassium. Next, which one is earth alkaline metal? Actually, it is alkaline earth metal. Alkaline earth metal. Okay, the answer is strontium. What are the alkaline earth metals? Actually, alkaline earth metals are within group 2. Alkaline earth metals are within group 2, and group 2 can be remembered in this way: biryani, moglai, kabab, shoriye, batite, rakho. Beryllium, magnesium, calcium, strontium, barium, and radium. Strontium is there, so strontium is the correct answer. Which is produced when NS1 metal reacts with water? Certainly base. Actually, NS1, it means group 1. And group 1 metals are known as alkali metals. Why? Because when it reacts with water, it vigorously reacts with water to create or generate bases or alkali. But the alkaline earth metals are also known as alkaline metals because they tend to react with water, but not in a vigorous fashion like group 1, but they do react with the water. But this is the reason for the word of alkaline, the word alkaline in its name. But the word earth actually is there because the carbonates and the oxides of group 2 elements are found in the soil. That's why they are called alkaline earth metals. Which of the following is a stronger base? Such questions are also common in other chapters as well. Stronger base would have higher Kb, right? The bases which possess higher value of dissociation constant will show higher strength. In this case, potassium hydroxide is the correct answer because potassium hydroxide possesses more Kb than sodium hydroxide. Calcium nitride reacts with water to form calcium hydroxide plus X. What is X? Actually, we have to determine X. See, there is nitrogen, there is hydrogen, so it should be ammonia. It should be ammonia. Which of the following is a s-Bloch element? S-Bloch element, it is a repeat question. We have already solved it. It is potassium. X metal in flame test shows a golden yellow color. We all know that golden yellow color in flame test, it is sodium, and sodium is within the alkali metal. So the correct answer will be D. We should also know that which elements does not show any color in flame test. Flame test, no color. Which are those elements? The elements are beryllium, magnesium, iron, aluminium. Beryllium, magnesium, iron, aluminium. We can remember this like Baba Ma Pire Elo. Okay, in this way we can remember all those elements which does not show any color in flame test. Which salt reacts with concentrated sulfuric acid to produce sulfur? Actually, the answer is sodium fluoride. Sodium fluoride reacts with the concentrated sulfuric acid to produce the sulfur. Which one is an alkaline earth metal? Alkaline earth metal actually within the group 2, so it is calcium. Which compound has more electric conductivity in aqueous solution? Actually, this is also asking about the strongest electrolyte here. Here we can see lithium chloride, sodium chloride, calcium chloride, carbon tetrachloride. Which one is stronger electrolyte? Actually, the answer will be sodium chloride. Since lithium is smaller, it has the potential to polarize the chloride ion. So the more will be the polarization, the more will be covalent nature. Since covalent nature will reduce the electrolytic nature or will decrease the electrolytic nature of that compound, so certainly sodium chloride here gets the upper hand than the lithium chloride. In case of 43, third question, which oxide is basic? Magnesium oxide is certainly basic because it is within the group of alkaline earth metal. Which compound is ionic hydride? Actually, sodium hydride is also ionic hydride. The rest of them are actually non-metallic hydrides. What is the electron configuration or electronic configuration of sodium? It is very easy: 1s2, 2s2, 2p6, 3s1. This one is correct because if we sum up we add up the electron number, it will be 11. What is borax? Borax is a very useful agent. Actually, it is used as flux to minimize or to decrease the melting point of a ore. Here, we encourage you to remember the formula, which is sodium 2, boron 4, oxygen 7, Na2B4O7.10H2O. It is also known as Shohaga in Bangla, but in English it is called borax. Which is the correct order of basicity? For the hydroxides, I should write down over here. For the hydroxides, solubility, decrease. Solubility actually did not decrease, it will increase in a group from up to down. So from up to down in a group, solubility of a hydroxide gets increased. So highest soluble will be cesium hydroxide. Okay, I mean, if I write down the members in a serial fashion, it is like this: Li, Na, Ke, Ru, Bi, Shajiyeche, France. So now if I convert them in hydroxide, we can easily say that the solubility will be more in case of francium hydroxide. So francium hydroxide will be strongest base here. Next cesium hydroxide, then rubidium hydroxide, then potassium, sodium, and lastly, with least solubility, the answer will be lithium hydroxide. And this order can be seen in option A. So option A will be the correct answer. Okay. In which of the following pairs are the two elements in the same group of the periodic table are there? Okay. Two elements of the same group: magnesium, barium. These are the two elements in the same group. A p-Bloch element in the periodic table whose last electron enters into the s orbital. Last electron enters into the s orbital. I mean, which one is the s-Bloch element? It is certainly helium, because arsenic, gallium, indium, these are p-Bloch elements. But actually, Gosar found it wrong. I mean, he designed the question in a wrong way because it is not a p-Bloch element. Helium is not a p-Bloch element. This question is scripted in a wrong way or mistakenly typed in. that helium is a p block element. Helium is not a p block element. Helium is a s block element. You should know that. Helium is a s block element, not a p block element. Characteristic of potassium cyanide. Potassium cyanide, it is extremely toxic. We all know about the cyanides. Cyanides are really toxic. It can interact with our respiration, which are located after the alkali metals. After the alkali metals, we get to see the group 3. And actually, after alkali metal, we don't get to see the group 3. After alkali metal, we get alkaline earth metals, which is group 2. So beryllium, magnesium will be the answer. What happens when water is added to sodium chloride? Sodium chloride gets dissolved, so it becomes sodium hydroxide and hydrofluoric acid. No, it just ionizes the sodium chloride. So option B will be the correct answer. The electronic configuration of the most electropositive element. Which one is the most electropositive element? Suppose this is the periodic table. Suppose this is the periodic table. Okay, let me make it better. Periodic table looks like this. Looks like this. Similar to this. This. Okay. Now it is perfect. So periodic table somewhat not like this actually. To correct it. It's moreover it looks like this. And let me draw one more quadrant over here to place the hydrogen. Okay. What I'm trying to say is that this is hydrogen, this is helium. Here we can also say that there will be lithium and beryllium. And now, if we look at the periodic table, we can say that from left to right, electronegativity will increase. So the member or element with highest electronegativity will be located here, which is fluorine. Fluorine got the highest electronegativity. So from right to left, the electronegativity will decrease and electropositivity will increase. But electronegativity decreases from top to bottom. So electropositivity will increase from top to bottom. So element of highest electropositivity will be located here, which is francium. Now, this question is asking what is the configuration of francium. Francium is located at 7th period, group 1. So what should be the answer? The answer should be xenon 6s1. What kind of metals are calcium and magnesium? Calcium and magnesium are alkaline earth metals. And what will be the M metal? If 2 electrons leave metal, it will become alkaline earth metal. Which element has valence shell electron configuration like Ns2? It will be alkaline earth metal. Which of the following alkali metal is the most reactive? We know the reactivity increases from top to bottom, so the answer will be cesium. Which inert gas is an S block element? Certainly helium. Which of the following is included in S block? It is certainly. Which of the following? Certainly helium, because boron, nitrogen, oxygen, these are P block elements. I'm solving it quickly because these are very easy questions to solve. What is the atomic radius of sodium? Lincoln's book contains such a question. It is 157 picometer. The atomic radius of sodium is equal to 157 picometer, which is most stable. Actually, I don't recommend you to remember all the metallic radius or atomic radius or ionic radius, because such questions is not appearing in the recent admission test. So why do you have to take such burden of memorizing all those numerical letters, which will be of no use after the admission test? Which is most stable? Most stable, I think, beryllium, because if you look at the configuration of beryllium, it is like this: 1s2, 2s2. We know that half-filled and full-filled orbitals are stable, and S subshell containing the maximum or electrons that they can hold certainly represents their stability. So the answer will be beryllium. Which oxide is highly basic? We know that metallic oxides are basic and non-metallic oxides are acidic. Here, N2O5 will not be an answer because it is a non-metallic oxide. Silicon dioxide is actually amphoteric. It's not amphoteric, it's slightly acidic in nature. Magnesium oxide and sodium oxide, which one is the correct answer? Actually, in between these two, sodium oxide is highly basic because it has the higher potential to ionize. Magnesium got higher charge. You know, higher charge means higher polarization. Higher polarization means more covalent nature. What is polarization? Polarization means attracting the cloud of the anion by cation. Once cation starts to pull the electron cloud of the anion, then the electron clouds get shared, and the sharing nature of a bond represents the covalent nature, which also responsible of laser dissolution or laser dissociation, which is actually not fulfilling the question, which is asking what is the which oxide is highly basic. For highly basic nature of an oxide, I think its solubility will be higher, and in this case, sodium oxide shows superior solubility or superior basic nature than the magnesium oxide. Now, in this F block element, again, we will find such numerical questions like what are the how many members are there in this F block, and also we will find some questions regarding the properties. And for this F block element, I only recommend you to focus on the property. Some important characteristics are there which are very prone to appear in the admission test. So you have to find out all those. Actually, you may find it in your book in this way, like the characteristics of lanthanide elements and the characteristics of the actinide series elements. And in the bottom portion of that list, you will find the delicious questions or informations that might appear in the admission test. What is the number of inner transition element? Inner transition element is similar to transition element. The ion, the stable ion, which contain 1 to 13 number of electrons in their F orbital or F subshell, these are called inner transition element. We know number of F block element is around 27, but inner transition element is 28. I mean, there is one extra element which is not F block but inner transition. As we all know, a proverb in Bangla that Shambhodoshe Loha Bhashe. I mean, great company can make you great, a bad company can make you bad, not bad. So thorium is a D block element, but it stays within the actinide series elements because there was no room to occupy or to accommodate 2 elements in 7th period group 3. That's why characteristics of thorium a bit mixed. It is somewhat like D block element and somewhat like F block element, and that specific property placed him in this elite group called inner transition element. That's how the number became 28. 27 plus thorium, the number became 28. So the answer will be 28. Which one is an actinide element? It is also very easy to answer. It is thorium. What is the number of F block element? The F block element will be 27. F block element 27, I have already discussed that. Which of the following element is not an F block element? For this type of question, you don't have to remember all the elements of F block. It is quite difficult. You have to remember at least 27 elements. I mean, lanthanum, actinium, lutetium, lawrencium. You can recall all these 4 easily because of their positions in their series. But lanthanum, actinium is not within the F block. These are D block elements. Lanthanum, actinium, thorium. These 3 elements are within the D block. You can only remember the lutetium and lawrencium, but rest of the elements are not that important. If I try to answer this question, let's go through it. Stannum here will not be an answer. Why? Stannum here will not be an answer. Why? Because stannum is within the P block. And also thorium will not be the answer. Why? Because it is within the D block. Neptunium and cerium, which one is the correct answer? Now this is the time where actually, oh wait, here question is which of the following element is not an F block element? Is not an F block element. So answer will be D and answer will be B. B and D, both of them are correct. Stannum and thorium, these are not D block elements. These are not F block elements. These are D block elements. Actually, stannum is not D block element. Stannum is P block and thorium is within the D block. That's why both of them are correct, as they have asked that which one is not within the F block. F block elements belong to which group? Very easy to answer. It is group 3. So the answer will be 3B. Again, I'm repeating. B subgroup contains the D block and F block elements. A subgroup contains the S block and P block elements. Which of the following is F block element? Certainly the answer will be cerium. Actinium, thorium, lanthanum. These are not F block elements. These are D block elements. Which one is actinide element? Though thorium is a D block element, but it falls within the actinide series. That's why I can say that this is the actinide element and it appeared in the admission test 16-17 session. Rest of the options are not even near to the actinide series. Okay, in this question, again similar question, which is the inner transition element? Cobalt, platinum, osmium. Nowhere near to inner transition. The only possible answer here is cerium. Which is the property of F block element? F block elements are quite opposite to S block elements. They are heavy, they have high density, they are more metallic in nature, they have high melting point, boiling point and all, and mostly they got some special group of different, they have an inner group within the block, which is inner transition element, which is not found within the S block elements. So for soft, the option A is not correct. This is applicable for S block. Sodium, potassium, these are very light metals. In fact, sodium can be cut with knife, and sodium has some other properties to remember, like you have to preserve sodium within kerosene, not in water. Such information you already know. It is not a hard metal. Heavy metal can be an answer, but hard metal is not the answer. So yeah, option C got the correct information that we seek. So the correct answer will be C, and none of this will not be an answer. What is the maximum electron carrying capacity in F orbital? F orbital have 7 rooms, and in each room there will be highest 2 electrons, so 7 into 2, it will be 14. Okay, the correct answer will be 14. So that's all from our side. You should practice it, and I think the topics that I have discussed in this lecture are very easy. One thing you have learned from today's class, that how to determine the period and group without any hassle in an exam hall for solving the MCQ. I think you should practice on that, and rest of the information that I've shared are really important, but I think easy to remember. And also I suggest or recommend you to go through the property chart of F block element. I mean, in the book you will find lanthanide series elements and actinide series elements. You will also find a refined chart of having much more information in the book in a well-organized manner in the matrix. You can also revise from that. I think that would cover up all the information that you need for this from this topic for the admission test. Best of luck.